here we're going to check some examples for the content in section 5.2, and this is a couple of integrals that are representing what happens below the equation of certain line and below a quadratic. So in the case of the line, it's easy to approximate the interval that we have given. Notice the equation of the line is represented here on this side, and we have that from 0 to 4 is going to have a piece of the area above the x-axis and another piece of the area below the x-axis. Now we can approximate that area with the sum of two triangles, of the area of two triangles. So area 1, which is above of the x-axis, plus area 2. Now area 1, notice, is going to have base 2 and it's going to have height 4. So it's 2 by 4 divided by 2. And similarly, the area below the x-axis is also going to have base 2, height 4. But the problem is that this is going to be below the x-axis, and that's going to produce the following. So what's going to happen with the integral is that although the area is not 0 for whatever is covered, the integral, it is going to be 0. And this positive area is going to cancel out with this negative area that is given in there. In some cases, like the case of a minus 2x squared, we're not going to be so lucky that we can approximate with just squares or triangles. In this case, notice that I can approximate this figure with two big triangles, but there's a lot that is left to cover. I could potentially approximate this these two areas, and I'll have this is going to be here 2 times 8 divided by 2 with this triangle, and plus, and we're going to have a minus from the negative area. And see that we have a base of 2, but we're going to have a height of around 23. So minus 2 by 23 over 2. Okay? And so that's producing 8 minus 23. And we're going to be left with an integral that is going to give us a negative value. So as you can see, the notion of integral under the curve is not necessarily going to yield us a positive results unless we are working with positive functions. Now consider the following integral. In this case, we're going to be able to find the area below the curve by splitting the area on two geometric figures. So if we take everything from here to here, notice that we can assign some sort of rectangle to this area, and we're going to have a triangle from here. We can easily find those areas as we have information for everything that we have in there. So notice that the rectangle has a base of 3, and it has a height of 3 as well. While the total of this is going to be 9, that means that this height for this triangle is going to be 6. So the area of the triangle is going to be given by the base, which is 3, by the height, which is 6, divided by 2. And so this is going to be 9. Now the area of the rectangle is going to be base, which is 3, given by height, which is 3 as well. And so that's also 9. So in this case, we can claim that the integral from 1 to 4 of 2x plus 1 dx is just the sum of these things. 9 plus 9, so it's 18. Now what happened when we don't have the area included on the exercise? Well, essentially we have to build it ourselves. Consider the integral of 1 to 6 of 2x minus x. And let's assume that we don't have any more information. At least we know that this is the equation of a line and it has positive slope, and when this crosses 0, this is going to be minus 6. So we have this piece here. Now this is going to be crossing 0 when x is equals 3. And it's going to continue, and when we have x equals 6, we're going to have this little piece over here. So this means that we're going to have two different areas. We can talk about this negative area over here, and we can talk about this positive area over here. They're both given by triangles, so we can find easily the area. So the area of the negative part, which is this, is area of the first triangle. The base is 3. The height is going to be 6 divided by 2. So again, this is 9. On the second circle, the base is still 3. And notice that when we plug in 6, we get 12 minus 6, so 6. So we're also going to have the same result. But because this is one negative area, one positive area, this is going to be 9 minus 9, and the integral is in total 0. Now let's go with another integral, which is going to be the integral of the absolute value of x multiplied by a minus between minus 2 and 3. So we can construct the area of this by recalling what the absolute value graph is. The absolute value graph, it looks somewhat like this, like a triangle. And if we're going to have the minus, that's going to cause a reflection. So that's going to cause a reflection on the axis, and we're going to have this type of area. So now we care about minus 2. So minus 2, absolute value of minus 2 is 2. But because we have a minus in front, then that's going to produce a minus 2 over here. So the first triangle that we're obtaining is this one. Now on the other side, we get from 0 to 3, and of course that's going to produce a minus 3. So I can talk about minus 3 being over here. And so this piece in the middle, the space and this piece, are going to end up being the areas that represent the area under the curve of minus absolute value of x. Notice this is going to have base 2. And also it's going to have height 2 as well. So the area of the first triangle is going to be 2 by 2 over 2. And the area of the second triangle is going to be 3 by 3 divided by 2. So this is 4 halves and 9 halves. Like they're both negative areas, then this is going to be minus 13 over 2. And that's some examples where we can calculate the area under the curve with trigonometric and geometric figures.